Greetings and welcome, friends. Mr. Waddy and my friends in real life here, my algebruddies. We are going over this concept of transformations of graphs. And the graphs that we were looking at were graphs of lines, which is right now the only thing we know how to graph without using a table of values. And when we transform them, you can kind of see horizontal and vertical transformation sort of things as a possibility. We could stretch and smoosh them, is what we're going to talk about today. You can reflect them, we'll talk about as well. And lines aren't the best examples of this because it's kind of hard to tell, was this a vertical transformation or a horizontal transformation? Because the same line could have landed in the same spot using kind of multiple means. But this concept of transformation is going to apply for all functions for really the rest of your mathematical careers, where you'll be able to see those things and be aware of kind of how they work. So we'll do some more practice with those over the next 3 days, but it's going to be good. So it says, use graphs f and g to describe the transformation from the graph of f to the graph of g. So f of x was equal to negative 2x plus 0, so it had a slope of negative 2, a y-intercept of 0, right? So here's the y-intercept, just to remind us how to do that. And the slope was negative 2, so notice it went down to and over 1 and down to and over 1, Jimmy and Amity, right? So we've got some values like that we could find from that graph. And then they showed us the function f of x plus 2, and the plus 2 is on the outside of the parentheses, and that is going to result in a vertical shift up 2, exactly. All right, it moves every single point on this line up 2 units. Everybody got moved plus 2. If you imagined a table of values, we would have had our x values, our f of x values, and then f of x plus 2, right, if I did that, would have just added 2 to all of those previous y values, right? And that would have resulted in only the y coordinates being increased by 2. All right, so that's why it's a vertical shift. Let's see, here they had us do one where we actually had to kind of graph it ourselves. Let's see, Ethan, what is the slope of this first one? What's the coefficient of the x term there? Let's see, it's going to be the 1/3, so we'll do an up 1 over 3. And the y-intercept, our starting point, is going to be the 3. So y-intercept is at 3, and the slope is 1/3. It's positive, so I'm going to go up 1, it's rise over run, over 3. Up 1 and over 3, like so. All right, so you guys are experts at graphing lines in slope-intercept form at this point, I believe. Right? I think so. We're getting good at sloppy intercept form. Good times. But now we're going to think about how I could graph this other function by interpreting it as a transformation. So if I was to take my purple line here and subtract 3 from it, right? So this is f of x, and then they told me that g of x is equal to f of x close parentheses minus 3. Yep. So I would move every point down 3 units, Jimmy. Every point down 3 units. Even though like the decimal and fractional ones would have gone down 3 units. And I can get a new line that way. So g of x is going to be a vertical shift. Sometimes my v's look like backwards r's or something like that. So Amity and Jimmy, well, still, let's have one conversation at a time, but feel free to participate. Vertical shift down 3. All right, so because this was a negative 3, it's being subtracted, I'm shifting everything down 3, like so. What was your question? Sorry. Ah, cool, sweet. That's the best when I like answer questions. And notice that let's see. I guess I'll make it a blue line here. I don't think I have anyone for ace today. I have a meeting today. So here's the function g of x, and notice everything's been shifted down 3 to get it. Okay, so that was the first type of transformation we had seen. Are you referring to like these arrows? Yeah, we should, because lines go forever, Amity, right? And that's why I draw the arrows on the end. In geometry, we would call a line that stops. We wouldn't call it a line. We'd call it a segment. Segment. You could have a ray, where it has a beginning but then never ends on the other side. And a line goes infinitely in both directions. All right, so segment, ray, line. There's some preview of geometry for you. All right, let's see. Y equals mx plus b, or f of x equals mx plus b. Jimmy, what is the m here for this equation? What's the slope? Yep, right? The 1/2 is the slope. It's just the number in front of the x. It's the coefficient. And Jimmy, what's the y-intercept, the b? Right, I like it. Man, I knew we were becoming experts at this. This is good. Right, graphing with a slope-intercept form. So begin at the y-intercept, and then move by our slope. So up 1 and over 2. Right, up 1 and over 2. Up 1 and over 2. And then, because fractionally positive 1/2 is also equal to negative 1 over negative 2, that was not a 2. There we go. I could also find other points if I wanted by going down 1 and backwards 2, which isn't necessarily that helpful in this instance, but sometimes if, say, I was going to go like up a bunch and over a bunch and I was going to land off of the graph, maybe if I was like stuck up in this corner, I could then, go the other direction on my line to be able to find those points and plot them a little more easily. So, yeah. Well, let's see. This one says g of x equals f of, and guys, this is a big idea. This is tricky. X minus 3. Now, because the minus 3 is on the inside, right? Inside, that tells me it's going to be horizontal, right? It's inside the parentheses. And horizontal transformations are the opposite direction that you might have first suspected. Okay, so in x minus 3, right, here's the positive x-axis, here's the negative x-axis. I would think, oh, negative 3, I want to move to the left 3 because that's towards the negative. But the trick is that it's the opposite. So this is going to be a horizontal shift. And instead of left 3, I'm going to go right 3. All right, that is the tricky part. So you've got to remind yourself that it's going to be the opposite direction for the horizontal shifts. So I will take every point and shift right 3 units. Question? Comment? Yep. And so I just kind of need to pick like a handful of points here and shift them over like so. Shift them over. Right? And yeah, that's not that bad. And these lines are actually going to end up being parallel, Jimmy. So I don't even need to change my slope on them. And for lines, the difference between horizontal and vertical shifts, I don't think is like terribly obvious, because there actually would be a way to find an equivalent outcome that would have been some vertical shift. All right, but that's not what they gave us. I'm just saying, like, graphically, it doesn't jump out at me that it was a horizontal or vertical shift. If someone just showed me those two lines, I wouldn't know which way it was shifted. Theoretically, it could have even been shifted diagonally, right? Okay, so whereas once we have like a crazier looking function, if I shift that function down or right, we're going to have much more clarity about that, and that's what we'll have tomorrow and the next day. Let's see. I don't know. I'll find out later. Don't worry about it. Yeah. Don't worry. I teach the stuff that'll be on the test. You'll have plenty of practice problems. It'll be good. Yeah, it's also on the Wadi curriculum calendar, right? So it says use the graphs of f and h to describe the transformation. So notice the original function was this, and then they said h of x is equal to f of the opposite of x. So because this is on the inside, this is going to be a reflection. It's a mirror image over what line? Well, when I opposite the inside, it's going to be a reflection over the y-axis. All right. Over the y-axis. Amity, you getting this? It seems like you're very distracted and possibly distracting up here. So let's do one more of these. So let's graph this one. Cameron, for y equals mx plus b, I'm looking here. What do you think the m would have been on this one? What do you suspect, eh? What's the m in y equals mx plus b? So the m is going to be the number in front of the x. What number is it? What's in front of the x here? Yeah, 1/4. I like it. I like it. Teamwork. Actually, no, you did it solo, but like you were encouraging your teammate. I like that. All right, and what's the y-intercept? What is the b part here, guys? That'll be the -2. That sign goes with it. All right, so y-intercept at -2. You guys are expert graphers. Up 1. I did go down 2 for the y-intercept, but notice the slope is positive 1/4, so that's why I'm going up 1/4. Pooja, what was your question? Let me find out. I haven't. We start where b is, and then we go up this number and over that number. So if this was like a 3, then I would have gone up 3/4. Yeah, I think we might have at some point. All right, so here's my first line. Now, if I want to transform this, now this one's not a translation. This one's going to be reflection. Pooja has a prediction as to what it will be. You don't? I thought you did. I thought you did. Now, guys, check this out. If I have x, f of x, and then the opposite of f of x, right? This is oppositing, right? Here's the input, and here's the output. This is oppositing the output. The output are the y values. So I'm going to change the y values. So if I have a y value, well, let's actually pick a point here. Here's the point 0, -2. So 0, -2. What's the opposite of? Yeah, it's going to be +2. So this point will now be up here. All right, let's pick another point. Here is 4, -1. And now the -1 would become +1. All right, so this point is now up here. How about this point? This one's interesting. That's 8, 0. And the opposite of 0 is 0, so that gets mapped to itself. So yes, Pooja's prediction was correct. It's going to be a mirror image over the x-axis. So that's h of x. So this is a reflection over the x-axis. So guys, difference with reflections. If I have an opposite on the outside of the function, it flips the y-coordinates, or it reflects it over the x-axis. If I have the opposite on the inside, it's going to change the inputs, right? So that's the x-coordinates, and that's a reflection over the y-axis. That's enough that you might want to like write that down on a note card and memorize that at some point. But thank you for watching, Internet friends. Have a great day.